students. Today we're going to be going over the lesson of factoring polynomials GCF. And so this is going to be very similar to the lesson that you're going to be going over in Edgenuity. I mirrored it very similar to your assignment as well. So let's go ahead and begin. Let's go ahead and begin with what a GCF is. And so what a GCF is it's your greatest common factor. Now what that means is that's the largest number that evenly divides into both numbers. And so evenly here you want to make sure that it's giving you a whole number. Okay, there's also another term that we want to look at, which is prime numbers. This is going to help us as we go on into our examples here in just a few minutes. And so what a prime number is prime numbers are whole numbers that have only two factors, and that's 1 and the number itself. Okay, we need to know that because that's going to help us right here in the method 1 that we're going to be going over. And so let's go ahead and take a look at our first two examples of the lesson. So the first one, the first two lessons go hand in hand. What I'm going to be doing is I'm going to be showing you two methods on how to find the GCF of two numbers. Okay? Method 1 is very similar to the method that you're going to see on Edgenuity, which is the program that you have for the lesson and the assignment. Method 2 is going to be a little bit different, and then you can go ahead and decide which method that you would prefer to use, whichever one is most convenient for you. Let's go ahead and look at the example using method 1. So the question says, what is the GCF, also known as the greatest common factor, of 44 and 110? So let's go ahead and let's find our greatest common factor, 44 and 110, using the method very similar to the one on Edgenuity. So I'll go ahead and I'll start with 44. Okay, so what we're going to do here is for 44, we're going to go ahead and we're going to write two numbers, or we're going to find two numbers that we can multiply that will give me 44. And you can start with any two numbers, 1 and 44, 2 and 22, 11 and 4, whichever two numbers that you prefer. I'll go ahead and I will start with 11 times 4. And we're going to create kind of like a tree, okay? And each branch is going to be numbers that you can multiply to give you the 44. Now we're going to keep extending these branches as far as we can until we reach a prime number. Once you reach a prime number, you can't extend that branch anymore, that number into branches anymore. Okay, so let's look at both of these numbers here. We have 11. 11 is a prime number. You cannot divide 11 evenly by any other number other than 1 and itself. So we're done here on the left side. Let's jump over to the right, which is the number 4. Well, the number 4 is not a prime number, and you can go ahead and you can find that 2 times 2 is equal to 4. Now, we could keep going if we have to, but as you can see here, the 2 and the 2, that is a prime number. It's only divisible by 1 and the number itself, and so we are done with the 44. Now, let's go ahead and let's go over to 110. Again, you want to find two numbers that you can multiply that will give you 110. I'll go ahead and I will choose 11 times 10. 11 times 10 gives you 110. Okay, now again, we want to keep going and extending these branches, but once we get to a prime number, we're going to go ahead and stop. So 11, as we just saw in the other example, is a prime number, so we cannot extend it anymore. The number 10, we can. 10 is not a prime number. It is divisible by 2 and 5. Okay, then we jump down to 2 and 5. 2 is a prime number. 5 is also a prime number. So we have finished. Now the next step that we need to do is we need to now write out these numbers, these factors that we ended up with at the end, the prime ones, for 44 and 110. Okay? Then we're going to find which numbers they have in common, and that's how we find the greatest common factor. So for 44, we had 11, 2, and 2. So 44, and we had 11 times 2 times 2. Then for the 110, we had 11, 2, and 5. So for 110, we had 11 times 2 times 5. Okay, now what I want to do is I want to see which numbers do these, or which factors do these two numbers have in common. And so we can see that they both have the 11 in common. I'll go ahead and do it in different colors. So we have 11 in common. And then we also have, let me fix that a little bit so we can make sure that we see the 11. So they have 11 in common, and they also have the number 2 in common. And so what I'm going to do here is I'm going to take the 11 and the 2. 11 times 2 is 22. So 22 is the greatest common factor of 44 and 110. And so here is my final answer, 22. Okay, so that's method 1. That one is very similar to what you see on your Edgenuity program. Now let's go ahead and take a look at the same numbers. We're going to find the GCF of the two numbers, which we already know the answer to. But I'm going to show you a second method. And again, you can decide which method that you would like to choose once you are done and once we continue with these examples. So 44. Okay, let's start with 44. So what I'm going to do here is I'm going to list all the factors of 44. Okay, so 1 times 44, 2 times 22. You can keep going. Again, if you don't know how to find the factors, you can always use your calculator and you can divide. Again, we're looking for numbers that evenly divide, which are going to give us a whole number. So we already know the 44 divided by 2. We tried that one. We knew it got 22. You can keep going. 44 divided by 3. Notice that gives me a fraction, so that is not a factor. 3 is not a factor. You can keep going. 44 divided by 4. That gives you 11. So you notice that this is a whole number, so that means that 11 and 4 are factors of 44. So we can do 4 and 11, and you can keep going. But right now, these are all the factors of 44. You have 1 and 44, 2 and 22, 4 and 11. Okay? Then you can go ahead and you can now find the factors of 110. Now, I also wanted to show you something that you might have been shown back when we were in school. And that is to find the factors of the number, you can actually graph the number. And so if you downloaded the software for our TI Inspire, you can use this method as well. And so what you can do is you can put 110, you divide that by x, and you press enter. Then we can go to our table, which is Control-T, and the table will actually list the factors of the number. Now remember, we are looking for whole numbers. So let's look at the first one, 1 and 110. Okay, and we come back, 2 and 55. Keep going. We have not a 3, that doesn't give me a whole number, neither does the 4. We have 5 and 22. And we keep going down. We have 10 and 11. And 11 and 10. Now, once the numbers repeat, that means that you have found all of the factors. And so now what we can do is now we can check to see which number, which is the largest number that both of these numbers have in common, because it's called the greatest common factor. And so you can see here they do share a few numbers. They share the 1, the 2, but ultimately the largest number that they both commonly share is 22. And so our greatest common factor between 44 and 110 is 22. So your GCF is 22. Same thing, same answer as we got there in method number 1. And so again, you can now decide which one is best suited for you, either method 1 or method 2. All right, let's now go ahead and let's move on to the next part of the lesson. Okay, the next part of the lesson is finding the GCF of monomials. Okay, so we have 2 examples here, and I'll go ahead and work out both of them. Very similar to what you see there on your program as well on the Edgenuity in the instruction part. Let's look right here at this first example. This first example says, what is the GCF, so your greatest common factor, of x squared and x to the power of 5, or x to the going to do here is we're going to kind of expand these monomials to what this actually represents. So what does the x squared represent, and what does x to the 5th represent? So we'll go ahead and we'll start with x squared. And so what x squared represents is it represents x times x. So that number 2 lets you know how many x's you are multiplying. Okay, now let's look at x to the 5th. Well, x to the 5th is x times x times x times x times x. 5 x's. 1, 2, 3, 4, 5. Now, very similar to what we just did up there on the examples that we just finished with the method number 1, as well as method number 2, is we are trying to find what do these two monomials have in common. Again, the C represents common. That's what we're looking for. That is the kind of the gist of the lesson here, is what is in common. And so we notice here, how many x's do they have in common? Well, they share an x here. They share another x here. And so they have 2 x's in common. So our GCF, our greatest common factor, is x squared. 2 x's. They have 2 x's in common. Okay, so our answer is x squared, x to the 2. Okay, again, they have 2 x's in common. Okay, these are a lot simpler because you can really just look to see what is the smallest exponent. Which one has the smallest exponent? Because that's the one that's going to tell you what they have in common. So in this case, the smallest exponent was a 2. So the greatest common factor was 2. Because they can only have up to 2 in common, because that's the number that you see there in the exponent. So let's take a look here at this next example. So the next example is, what is the GCF of h to the power of 3 and h to the power of 6? So again, h to the power of 3 is the same thing as h times h times h. H to the power of 6 is the same thing as h times h times h times h times h times h. Okay, you have 6 h's. So you had 3 in the first one and 6 in the second one. Again, we want to see what do these two monomials have in common. How many h's do they have in common? Well, they have 1, 2, 3. Again, you can just take a look at which of the two has the smallest of the exponents, and that tells you what they have in common. So the GCF of h to the power of 3 and h to the power of 6 is h to the power of 3. They had 3 h's in common. All right? Now, this is kind of separating what you're going to see in the examples. I went ahead and showed you how to find the GCF of numbers, and I showed you how to find the GCF of monomials. And so now what we're going to do is we're going to put those two together, and we're going to see some examples as we go through the next part of the lesson. So let's go ahead and take a look at some questions here, some examples. And again, we want to now go ahead and put these two things together. So let's take a look here at this first example. This first example says, what is the GCF, so the greatest common factor, of 44j to the 3rd, k to the 6th, and 121j to the 4th, k to the 2? Okay. Now, this could look a little intimidating, but we're going to go ahead and we're going to take it step by step, very similar to the steps that you saw in the Edgenuity instructions. So let's start with the first part of solving this. The first thing we're going to do is we're going to find the GCF of the numbers. Okay, and the two numbers here are 44 and 121. And now this is where I told you that you can decide between the two methods. You can either use method number 1 or you can use method number 2 in listing the factors or using the tree to find which is the greatest common factor. So I'll go ahead and I'll start with 44. Okay, and I'll go ahead and take two numbers that I can multiply to give me 44, which 11 times 4. Now I can go ahead and I can extend the 4, which is 2 times 2. Now these are all prime numbers, and so my branch is in there. Now let's start with 121. Well, 121, we have 11 times 11. 11 times 11 is 121. These are both prime numbers, and so now you can go ahead and figure out what do they have in common. And so in this particular example, on 44 and 121, the only thing that they share in common is 111. Okay, the 44 had 11, and then the 121 has an 11. So the GCF of 44 and 121 is 11. Okay, that's the first part. And we'll go ahead and bring it all together at the very end. Now let's move on to finding the GCF of j to the 3 and j to the 4th. And so that's the next part right here. So the first part was the 44 and the 121. Now let's go ahead and let's move on to the j to the 3 and j to the 4th. Now again, you want to figure out what do they have in common. So j to the 3, that's the same thing as 3j's, j times j times j. J to the 4th is the same thing as 4j's. So 1, 2, 3, 4. And now we want to see what they have in common. Remember I mentioned that the smallest exponent is what they have in common. And so they have 1, 2, 3. They have 3 j's in common. So the GCF here is j to the power of 3. Because the smallest exponent was 3, and so that's how many they have in common. Lastly, we can go ahead and now find the k to the 6, k to the 2. Again, make it a little bit easier. Look at the smallest exponent. I'll go ahead and work it out for you. But k squared is the same thing as 2k's, which is k times k. And then k to the 6, that's 6k's. So we have 1, 2, 3, 4, 5, 6. You have 6k's. Now we want to see what we have in common. We have 1, 2 in common, which makes this GCF k to the 2. Now that we have found the GCF of the number, the variable j, or the monomial j, and then the monomial k, now we can go ahead and we can put this all together to give us a final answer of 11, j to the 3, and k to the 2. And that is your final answer. That is the GCF of 44, j to the 3, k to the 6, and 121, j to the 4th, k to the 2. Again, we broke it down. We started with the numbers, then you go on to your monomials, and again, you want to make sure that you separate your monomials, the j and the k, depending on what your variables are. So again, it could look a little intimidating at the beginning, but take it step by step and break it up into parts. So let's go ahead and take a look at the next example. Your next example says, which of the following terms have a GCF of 4p to the 5th? So what we want to see is we're going to be selecting two options here. And this is very similar to an example that you're going to see in your assignment. And so I wanted to go ahead and keep it very similar to that. You have two options here. So which of the following terms have a GCF of 4p to the 5th? So what you want to start with is just very similar to what we did here in this first example. Let's go ahead and start with finding which of these numbers has a GCF of 4, is the greatest common factor of 4. So which numbers here are divisible by 4? And that's what we want to figure out. So we'll go ahead and we'll look at the 12, at the 18, at the 16, and at the 25. Some of you guys are very good with numbers, and you can already figure out which ones are divisible by 4. And so I'll go ahead and I'll start with the 12. Okay, I know that 12 is divisible by 4. Now go ahead and write it over here because I know that 12 is the same thing as 4 times 3. Okay, now I can go ahead and I can move on to the next one, 18. Well, 18 is not divisible by 4. And the way that I know that is, I know that it doesn't evenly divide into 4. And I can figure that out by dividing. 18 divided by 4, when I press enter, it gives me a fraction, which is the same thing, equivalent to a decimal. Okay, 9 over 2 is equivalent to 4.5. One's in decimal, one's in fraction. Now, since it does not evenly divide, meaning it doesn't give me a whole number, then that means that it is not a factor. It does not have a factor of 4. So second answer choice is out, because if it's not divisible by 4, how can it have a greatest common factor of 4? It can't. Let's go on to the next one, 16. Well, I know that 16 does divide evenly into 4, okay, which 16 divided by 4 gives me 4. Okay, again, if you want to check that, you can go ahead and come on over to your calculator, and we can do 16 divided divided by 4 and press enter. And you see that it evenly divides. It gives you a whole number. So 4 times 4 is 16. Okay, that may also be an option. Now we take a look at the last one, which is 25. Okay, 25 is not divisible or does not evenly divide by 4. And you can see that here. You want to come back over to your calculator and you can do 25 divided by 4. And you can see that it does not evenly distribute into 25. Okay, you can press Control Enter, it gives you your decimal here. You can also use any basic calculator and you can see that it does not evenly divide. So that one is also not a factor, does not have a factor of 4. Now, if you look back up here, we knew that we only had to select 2 options, which are the only 2 options that we're left with. Now, we can just double check p to the 5, and we can see that, yes, both of them do have p to the 5. So we know that the greatest common factor of these 2 numbers is 4p to the 5. So my answer here is 12p to the 5th r and 16p to the 5th. Remember that we were selecting 2 options. Okay, so our greatest common factor of these would be 4p to the 5th. So notice how I took it step by step. I went ahead and I just started with finding the greatest common factor of the number first. Then I moved on to my monomial. All right, let's go ahead and now take a look at this example here. Again, I wanted to make these very similar to what you're going to see on your assignment. And so this is similar to an example that you're going to see as well. This example here says 3x to the power of 3 is the GCF of this polynomial, which could be the mystery term. And so you go ahead and you take a look here at this example. It's missing this last term right here. And so that's what it's asking you to find. It's asking which one of these answer choices could we place there that would go ahead and have a GCF of 3x to the 3. Again, we want to go ahead and take it step by step, and we want to start with finding the GCF of the numbers. So we can go through our answer choices, and we can see which one has the greatest common factor of 3. We can start with the 3. So which one is divisible by 3? Once we go from there, we can eliminate some answer choices, and then we can move on if needed. So let's go ahead and start with the first answer choice. The first answer choice is 14x to the 4th. Now let's check 14 and let's see, is 14 divisible by 3? Does it evenly divide into 3? And so I can go ahead and I can do 14 divided by 3, and I can press enter. Now I see that this does not give me a whole number, so I know that that is not a factor. 3 is not a factor of 14. So I can go ahead and I can cross that one out. Now let's go on to the next one, 24. Let's go ahead and divide. 24 divided by 3. Does it evenly divide? Yes, it does, and it gives me an 8. So that means that my factor of 24 is 3 and 8. So that's a possibility. Let's jump down to the next one, 26. Well, let's check out 26 and let's see, does that evenly divide by 3? 26 divided by 3. When I press that, you see that that does not give me a whole number. So since it doesn't give me a whole number, it is not a factor of 3 is not a factor of 26. It does not evenly divide. So that one is not an option. Then let's check the last one, 28. So 28 divided by 3. Let's check to see if that is divisible by 3. And we see here that it does not evenly divide. It gives us a decimal. So since it does not evenly divide, it is not a factor of 28. And so if you go ahead and, like I mentioned, we started with the first step, and I said if we had to go on to the next step, we would. But from the looks of it here, you have only one answer choice, and so obviously that has to be our answer. Now you can double check by looking at the x to the power of 3, and you notice that yes, it does have that x to the power of 3 there. So not only could you take out a 3, you could also take out an x to the power of 3. And my answer here is 24, x to the 3, y. It has a GCF of 3x to the 3. Okay, so just a little summary before we move on to the next part. We went ahead and we found the GCF, also known as your greatest common factor, of numbers as well as monomials. And now we found the GCF of monomials and polynomials. And so we put two together. We put the GCF of finding a number, the GCF of finding monomials, all together to help us solve these problems. All right, let's go ahead and move on to the next part of the lesson. So my next part of the lesson is pretty much the opposite of what we were just doing there in those examples above. And so the second part of the lesson is known as factoring the GCF from a polynomial. So it's a little different, but we're still using the same ideas that we were using from the examples before. Okay, so we see here. We'll go ahead and start with some information that you're going to need. Okay, we're going to start with distributive property. So a lot of you all have seen distributive property. When we use distributive property, we use parentheses. And when you use distributive property, the operation that you use is multiplication. And so let's take a look at what distributive property looks like. So let's just say, for example, you have A parentheses, B plus C, close parentheses. So what we do here is we distribute. You do A to the power of B, A times B, and then A times C, which gives you your final result here, which is A times B, plus A times C. So this left part of the distributive property is called the distributive part. So distributive. Okay. The second part, which is this part over here, this is your factor part. And so this is what we're going to be focusing on today. We're going to kind of be using both sides of this distributive property to help us to factor the GCF from a polynomial. So what we want to do is, let's go ahead and take a look at some examples here, and then we can go ahead and we can figure out the factored form of these examples. So let's take a look at example number 1. Now we're going to be using the same steps that we were using up at the examples that we just finished, where we were finding the GCF of the numbers, we moved on to the monomials, eventually into the polynomials, into the different variables that you see there. So let's take a look at this first example. This first example says, what is the factored form of the polynomial 14x y to the 2 minus 43x to y? So what we want to do is we want to start with step 1. Okay, so step 1 here is we're going to go ahead and we're going to find the GCF of the numbers, which is the 14 and 43. So GCF of 14 and 43. So what we're trying to do here is we're trying to, again, figure out what do these two numbers have in common. Again, you can decide whichever method it is that you want to choose to help you find the factors of these numbers. So let's go ahead and start with 14. I'll go ahead and list the factors of 14. We have 1 and 14, and we have 2 and 7. Those are my only factors of 14. Now we can go ahead and we can find the factors of 43. Now again, if you don't know the factors of 43, you can head on over to your calculator or any other resource it is that you're using to help you find your factors of 43. Do 43 divided by x, go onto your table, and let's see the factors that we have here. So we have 1 and 43. So let's write those down, 1 and 43. Now we can keep going. These are giving me decimals. Remember that we are looking for just whole numbers that evenly divide. And so as I can see here, if I keep going down, I don't see any other numbers that might evenly divide into 43. Okay, we can keep going down, and it looks like that 43 is a prime number. Whoops, I went way too far up. I went to the negative part of it, and I don't need to worry about negatives, but we had the 1 and 43. It's not divisible by 2, just not divisible by 3, nor by 4. And again, you could keep going and going and going, and you could see here that none of the other numbers are divisible. And you could go all the way down to 43, and you're going to see that none of these numbers here are divisible by 43. And so that makes 43 a prime number because it's only divisible by 1 and the number itself. So heading back over here to figure out what the GCF of 14 and 43 is, we can see that the only number that they have in common here is the 1. So 1 is the only number that they have in common, which is fine. 1 is a number. It's the greatest common factor of 14 and 43. Now let's go ahead and let's move on to the next step, step 2. Step 2 is now we're going to go ahead and we're going to find the factors of our first variable there, which is and the x squared. So we're finding the GCF of x, that's that first one right there, and x squared. Okay. Now x, well, there's just one x there. Now we have that imaginary 1 up at the top that we don't necessarily write, but we know that there is one x there. So x is the same thing as 1x. Now x squared, that gives me 2x's. So x times x. Now remember, we're looking to see what do these two have in common. Well, the only thing they have in common is 1x. And so the GCF is just an x. Now step 3. Step 3, we'll go ahead and find what is the GCF of y squared and y. So GCF of y squared and y. And so we have y squared, which is the same thing as 2y, so y times y, and then y by itself, which is y by itself. So let me fix that right there. So the only thing they have in common is a y. Okay, so we see here what they all have in common. They have a 1, they have an x, and then they have a y in common. And so what I'm going to do here is I'm going to move off here. I ran out of room here, but I'm going to go ahead and I'm going to rewrite this right here. So I have 14x y squared minus 43 x squared y. And so I know that they have a 1, an x, and a y in common. And so what I'm going to do here is I'm going to go ahead and I'm going to write that. Okay, I'm going to go ahead and I'm going to write the 1, the x, and then the y in common. Okay, they all have that in common. And so now what I'm going to do is I'm going to figure out what is left in the remaining polynomial once I take out a 1, an x, and a y. So if I take a look here at this first term, if I take out of 1, 14 divided by 1 is still 14. Okay, now I'm taking out an x, so if I take out an x, that means that I'm not left with any more x's. And then if I take out a y, well, I had 2 y's, but if I take out 1, that's still going to leave me with 1 more. And so I'll be left with a y there. Minus, okay, 43, well, 43 divided by 1, that's still just going to give me 43. Then I have x to the power of 2. Well, if I take out one of those x's, that's still going to leave me with 1x. So you have 1 and 1, which gives you 2. And then the last one, if I take out a y, well, I only had 1 y, so if I take it out, that doesn't leave me with any y's. And so I have now factored out the greatest common factors from that polynomial. So this is the factored form. Now, if you take a look here, we generally don't write the 1. The 1 stays as an imaginary. We don't have to write it there. And so my final answer would look like this. X, y, parentheses, 14y minus 43x. And so that there is my final answer. This is the factored form of the polynomial that you see here. So what I did was I factored out what was common amongst the number, the x's, and the y's. And I took those out because those are all common. Okay, they all have that in common in both of those terms of that polynomial. All right, let's go ahead and let's take a look at the next example. Okay, the next example here you see factors, 18b plus 42bw plus 30w. And so what we're going to do is we're going to go ahead and start with the numbers and do the steps as you just saw over there on the left-hand side. All right, so let's start with step 1. So step 1 here, we're going to go ahead and now we have 3 numbers that we have to find the greatest common factor of. So we have to find the greatest common factor of 18, 42, and 30. Okay, and again, you can decide which method it is that you prefer. I'll just go ahead and I'll list the numbers. I'll list the factors of 18. So we have 1 and 18, we have 2 and 9, we have 3 and 6. All right, let's go ahead and now take a look at the factors of 42. Okay, again, as you get into larger numbers, sometimes it's a little bit more difficult to find. find the factors. So that's where generally you can use another resource to help you, such as the calculator or any other resource it is that you're using to help you find your factors. And so I'll go ahead and use my resource of my calculator, and I'll go ahead and plug it in, head onto the table, and let's take a look at my factors there. So we have 1 and 42. I saw 2 and 21. I also saw 3 and 14. And let's keep heading on down. Let's see what other numbers that we see here. We have 6 and 7. And then it goes back to repeat 7 and 6, so we know that we have found all the factors. Now let's take a look at the factors of 30. We have 1 and 30. We have 2 and 15. And we have 3 and 5. And so those are my factors of 18, 42, and 30. Okay? And so what we're going to do now is we are now going to go ahead and see what is the largest number that all these three have in common. What is the largest number? And so I can just kind of skim through. Well, this one has a 3, this one also has a 3, and this one also has a 3. And so it looks like the 3 is going to be the largest number that evenly divides into all three of these numbers, which means that our GCF is 3. Okay, let's now go ahead and move on to the second part. So the second part is finding the greatest common factor of the variable, which is v. So the first term has a v. So let's go ahead and write this in. The first term has a v. Okay, the next term also has a v. And then the last term, well, if you look at it, it does not have a v. So it does not have a common factor of the v, because we're trying to check to see what do they have in common? What do all three of the terms have in common? Not just 2 of them, but we're trying to see all 3 of them. What do they have in common? So in this particular example, they don't even have a v in common. The first 2 terms did, but the third term did not. And so that makes it that it does not have a v in common. So let's now take a look at the third part of this example, which is the last variable, which is the w. Now, if you take a look at the first term, okay, the first term doesn't even have a w. So very similar to the second part of this example. Notice the third term didn't have a v, and now in this one, the first term doesn't have a w. Now, the second term did have a w, and the third term had a w. But since the first term didn't have a w, then that makes it that there is no common factor in terms of the v and the w. Now, we did see that it had the 3 in common, so we can go ahead and we can factor out a 3. We can take a 3 out of there because that is something that they all have in common. And so I'll go ahead and rewrite this example, or bring it down here, and it was 18b plus 42bw plus 30w. And so what I want to do here is I want to take out this 3. Remember that we found that that was the common factor. And so I'm going to go ahead and I'm going to factor out a 3. And now I'm going to go ahead and I'm going to write what is remaining in there. Now, all I'm taking out from these terms is a 3. So if I take out a 3 from the 18, well, that leaves me with a 6, because 18 divided by 3 is 6. Now I can just go ahead and leave the v. I can leave the plus sign. Now the 42, if I take out a 3 from the 42, that leaves me with 14. And then we have VW. And then the last term, if I take out a 3 from the 30, okay, that leaves me, and I went ahead and I made a mistake here. Okay, so we're going to go ahead and we are going to, 3 times 5 is not 30. 3 times 5 is 15. So let me make that correction here. That actually should be a 10. 3 times 10 is 30. So I'm sure hopefully some of you all caught that. But 1 times 30 is 30, 2 times 15 is 30, and 3 times 10 is 30. Okay, we make mistakes as well. I'm human. So now, if I take the 3 out from the 30, that is going to leave me with 10 and then the W. And so this now is my factored form of that polynomial that you see up there at the top. The only thing that those three terms had in common was the 3. And so I took the 3 out. Now notice, I've been using the word common quite a bit. Okay, the word common, because it's greatest common factor. We're checking to see what do all these 3 things have in common. All right, let's now go ahead and take a look at the last example here of the greatest common factor, or factoring the GCF from the polynomial. So we have 3 terms here. We have this term, and this term. And so again, we want to go ahead and we want to see what do these 3 terms have in common. So let's start with the first step. The first step is finding our greatest common factors of 15, 25, and 55. And so again, you can go ahead and you can list your factors. Of 15, we have 1 and 15, and we have 3 and 5. For 25, we have 1 and 25, and we have 5 and 5, and I think those are my only factors there. And then of 55, we have 1 and 55, and then we have 5 and 11. And those are my factors of 55, 25, and 15. And so what we want to do is we want to find what do these numbers have in common? What is the greatest common factor of these 3 numbers? So if I take a look, I can very quickly see that each of these numbers has a factor of 5. And from the looks of it, that's the greatest number that they all share. So the greatest common factor here is 5. Let's now go ahead and take a look at step 2. Step 2, we're now going to look at the r's. So we have r to the 4th, we have r to the 7th, and we have r to the 2. Now, as I mentioned back in the previous example, a very easy way to look at this is check to see which one has the smallest exponent. The one that has the smallest exponent is your GCF, because the smallest, that's the smallest amount that they all share, which is r to the 2. That's also the greatest that they share. If it only has r to the 2, you can't have any more than that. And so your GCF here is r to the 2. It's the smallest exponent between the 2, the 4, and the 7. Now let's go ahead and take a look at the third part of this example, which is the s. Okay, so the first one, we're going to go ahead and it has an s. The next one doesn't have an s, so kind of looks like the example we just did. And then the last one has an s to the 3. Now, the none part of it, let me go ahead and highlight that. I didn't highlight. The none part of it is what we're going to be looking at. It does not have anything. They don't have any s's in common. So what it does have in common is it has a 5 and an r squared. And so I'm going to go ahead and I'm going to rewrite this, and then we'll go ahead and factor out the 5 and the r squared. And I'll go ahead and write it off to the side so we have some more room. So we have 15 r4s plus 25 r7 minus 55 r2s3. Perfect. I got this in there. All right. So what we're going to do now is we know now that they have a 5 in common. So I'm going to take out a 5. And then we know that they have an r squared in common, an r to the power of 2. So I'm going to be taking out from each one of these terms, I'm going to be taking out a 5, and I'm going to be taking out an r to the 2. So let's start with the first term. If I take out a 5, that's going to leave me with 3. 5 times 3 is 15. If I take out 2 r's, well, 4 minus 2 is 2, so I'm left with 2. I didn't take out any s's, so it's going to just be left with an s. Now let's move on to the next one. 25, if I take out 5, it's going to be 5, because 5 times 5 is 25. If I take out 2 r's, I'm left with 5 r's, because 7 minus 2 is 5. And then the last one, if I take out a 5 from 55, I'm left with 11. If I take out 2 of the r's, r squared, well, that takes out all of them, and so I'm not left with any r's. But I am left with the s to the power of 3. And so here is my final answer. Once I factored out the 5r squared, I was left with 3r squared s plus 5r to the 5th minus 11s to the power of 3. Alrighty, we are down to the end. We are down to the last example here. Okay, so let's move on to our last two examples. So our last two examples here, okay, we're going to go ahead and we're going to take a look at the first example, and it's a real world example. They have now pertained this to the real world. So let's take a look here at this example. So it says, Ava is building a garden in the shape of a regular pentagon. Okay, that's some information that you need. Regular meaning that they're all going to be equivalent. All of the sides of the pentagon are going to be equivalent. And then pentagon, you should know how many sides a pentagon has. And a pentagon has 5 sides. Now it says the perimeter, that's also another keyword. The perimeter is 25 y to the 8 minus 55 x to the 4th inches. What is the length of one side of the garden? So again, we have a pentagon here. Okay, so this is what your pentagon looks like. Let's see if I can draw it here. We have a pentagon that looks similar to this, and all sides are equal. Okay, the perimeter. So the perimeter means that we're going to add up all the sides, and it gives you what the perimeter is, and it wants to know the length of one side of the garden. Well, a pentagon, as we just mentioned, has 5 sides. So what I need to do is I need to factor out a 5 so that way I'm able to see what is the length of one of the sides of the garden. And so I'll take my polynomial that I have here, which is 25 y to the 8th minus 55 x to the 4th. And what I'm going to do is I'm going to factor out a 5 because there's 5 sides. So I'm going to go ahead and I'm going to factor out the 5. And when I factor it out, I'm going to see what I'm left with. Well, if I factor out a 5 from here, I'm left with 5 because 5 times 5 is 25, y to the 8th, minus, and if I factor out a 5 from the 55, I'm left with 11, and then x to the 4th. So this part right here inside the parentheses, that is the length of one of the sides. Because remember, each side is equivalent. They're all equal. And so each one of those, if I multiplied it by 5, because the pentagon has 5 sides, that would be the length of each of the sides. And so my answer here is 5y to the 8th minus 11x to the 4th. That is the length of one of the sides of the pentagon. Okay, again, I divided it by 5. I'm sorry, I factored out a 5 because a pentagon has 5 sides. Okay, last but not least, let's go ahead and let's take a look at the last example. So this example here says, Max determined that 6a to the power of 3 is the GCF of the polynomial. And your polynomial, is C correct? And then we're going to go ahead and explain. So we are trying to see, is Max correct at determining that the GCF is 6a to the power of 3? So again, we're going to be using the same steps that we've been using for those past examples. So let's go ahead and start with the first step. So my first step here is we're going to find the GCF of the numbers because we want to see, is their GCF 6? So let's go ahead and take a look at that. Let's look at the first term. Well, the first term doesn't even have a number, doesn't have a coefficient. Now remember, I mentioned that generally when we don't see a number, we don't see a coefficient, we know that it's a 1. So there is a 1 there. So it's 1, and then we have 12, and we have 24. So let's take a look to see, do they all have a common factor of 6? Well, let's take a look at 1. Well, 1 is a prime number, which is just 1 times 1. 12 has factors of 1 times 12, 2 times 6, 3 times 4, and then we have 24, which you have 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay? Now we're checking to see, do they have a 6 in common? Well, if I take a look at the first term, the only term that one has is 1. And so technically, this does not have a factor of 6. So is Max correct? No, he's not correct. Okay, no. The only factor that they have is 1. Okay, the greatest common factor of the numbers 1. So we can put no, the GCF of 1, 12, and 24 is 1. Okay, so we already know that he is incorrect because the greatest common factor that he came up with was 6, and the greatest common factor is 1. So he is not correct. You could go on and keep going to find about the a to the 3. We can see that the first term does have a to the 4th, a to the 3. If you take a look here at the last term, it doesn't even have an a. So he is also incorrect because the last term does not even have a to the power of 3. It only has a term of b. So that is also why Max is incorrect in getting that answer. So I hope this helps, guys. I hope that you're able to use this when you are working on the assignment for factoring polynomials or GCF. Keep in mind that you only have to do the assignment for this one. We do not have a quiz. And so if you have any questions, reach out to your teachers. Let us know. Hope this helps. Have a great day.